Today we'll discuss about experiment number 2 of electronic circuit lab. The aim of the experiment is to build, simulate and test the single stage CS amplifier with and without bypass capacitor. So these are the objectives of our experiment. So first objective is what? We have to design the single stage CS amplifier. We have to connect some capacitors in that. We have to check the input impedance, output impedance, gain and the frequency response, that is bandwidth. The second objective is what? Again we have to build this MOSFET circuit without source bypass capacitor and again check its parameters. So we have to compare the parameters of each with bypass and without bypass. Again we have to check the frequency response with bypass and without bypass, and if we consider the shunt capacitance at the output side, what will be the effect of shunt capacitance on the gain or on the bandwidth. So one by one we can obtain this objective. So these are the outcomes. So the first outcome is what? Simulate using model simulation tool. We are using the multisim software for simulation purpose. So again we experiment it, demonstrate it, validate it and conclude the performance. So this is to be again implemented on the breadboard using hardware components. So we have to cross check both the results of hardware and software and then conclude about the experiment. Again we have to do some calculation with practical manner and with theoretical manner. So again we have to cross check our result of theoretical manner and practical manner. So these are the two COs which are mapped with this practical. So CO1 and CO2 are mapped. These are the list of equipments required. So we require the resistances as per the first experiment. The same circuit to be used, but we need to modify it with the help of capacitors. Then we required CRO on which we can obtain the waveform. When again we require the multimeter for finding the current. So and again for simulation we using the multisim software that I have already told. So these are the component lists with which we have already found the values or DRS and RG and RG2 in experiment number 1. Again we have taken the coupling capacitor value with 10 microfarad and the source bypass capacitance 100 microfarad. So these are the standard value. So why the source bypass capacitor having higher value? Because we required the less impedance or less reactance in that path. So as the C value is increased, so we can have the less reactance, that is X is equal to 1/2 pi FC. So this is the circuit diagram. So the main core of this circuit is simple and it is again the same as for the experiment number 1. Only we connected some capacitor. This is CC1, this is CC2 and this is a bypass capacitor. So this coupling capacitor CCI and CCO, these are called a coupling capacitor. Means what? We are connecting the AC signal source to the amplifier. So all the AC signal source to be get coupled with the input and all the AC signal source will be coupled with the output for getting the output on the CR and DSO. So the coupling capacitors are only responsible to couple all the AC input or the AC signal to the circuit. Now this is a bypass capacitor. So to improve the output, as in the last experiment we obtained the equation for this outer loop, that is VDD is equal to ID into RD plus VDS plus RD into RS. So if you eliminate this voltage drop across over RS, so it can increase the VDS value. So if you eliminate the voltage drop across RS, so that can be directly responsible to increase your gain. So we can use a source bypass capacitance over here which is having the low resistance. So that's why we're choosing the value which is more, that is 100 microfarad. So the current behave that the current will always acquire the low resistance path. So the total current can flow from this branch only and no current flow from this RS. So the voltage drop across RS is 0 because current is 0. So hence we can improve our output. Now first thing we'll see step by step. So we have to connect the function generator at the input side. We need to give an AC signal using function generator, that is sine wave. We have to choose the peak to peak value of it, the signal. We have taken here your 50 millivolt peak to peak value. So the AC input signal is connected to the coupling capacitor and this AC signal is fed to the circuit, and again with this output coupling capacitor we can get an output. So in the first step, we are directly connecting the 50 millivolt input signal, and only we are observing the output voltage on the CRO. So this is our first step. So now I again connected a resistor over here, that is RSG, that is source resistance, and again I have connected one RL over here, that is a load resistance. I have always again shown here a shunt capacitance. The shunt capacitance is nothing but the internal capacitance of this MOSFET. So if we consider the internal capacitance of the MOSFET, and if it is more, then what it will affect on your frequency response or bandwidth or gain, that will again going to observe. So the first step is what? Connect the input to the coupling capacitor and check the output. So the output is nothing but VO. So I just show you. Yes, procedure. So we need to connect the input signal with certain frequency. Okay, so we can take frequency, any frequency from 1 Hz to 1 kilohertz to 20 kilohertz. Okay, so we have to check whether the output is, what is the output for the first condition. So we have to connect the input supply, that is function generator, at the input side and check the VO. For the next step, we have to connect this RSG in the circuit. So we have to increase the input impedance of the network, or this can be called as a source input impedance. So this values to be greater than the RI value. So in the last experiment, we have to calculate the RI value. So RI value is nothing but this voltage divider network value. So if we calculate the RI value, so it is nothing but 20 into 10 upon 20 plus 10. So it will be around 6.6 mega ohms. So that is RI value, and this RSGB will be chosen greater than RI value. So here is written that RSG must be greater than the RI value. So in the second step, we have to connect this RSG. So we disconnect this input source and again connect to the A to the A double dash. So as A is connected to A double dash, again we have to measure the VO. So that VO will be VO dash. So we can see over here, the first step is what? Connect A to A dash. So we have connect A to A dash, and that time we have obtained the output voltage. Again connect A to the A double dash, connect A to the A double dash, and again output, that is VO dash. Then again connect A to the A dash, and now connect B to the B dash. So in the first stage, we have to connect B to the B dash. So this B is connected to the B dash, and again we have to find the output voltage VO double dash. So this is the first step. We have to find the VO, we have to find the VO dash, we have to find VO double dash. Now at the fourth step, we again connect A to the A double dash and B to the B dash, and again we find the VO triple dash. So this is what an output voltage. We are only checking the what impact of the input impedance and the output impedance will be on the gain. So that value we have to obtain. Again for the finding the bandwidth, again we need to change the value of shunt capacitance, and again we need to change the value of source bypass capacitance. So from this capacitance values, we again cross check what will the effect of the shunt capacitance and the source bypass capacitor on the gain and the bandwidth. So one by one we solve this, and after that we can put this value in some equations or some formula, and we can obtain all the theoretical and practical value. So these are the formulas. So in the first section, when we connect the RI, that is for finding the RI, when we connect the RSG in the network, so finding the RI, for that condition the formula will be RI is equal to VO dash upon VO minus VO dash into RSG. So this is RSG is nothing but the resistance connected at the input side. Again it will be greater than RI value. So that is the value of parallel combination of your voltage divider network. Now in the second case, we have to find the RO when RL is connected in the network. So RO is equal to VO minus VO double dash upon VO double dash. So using these two formulas, we can calculate the input impedance and output impedance. In the third stage is what? We again calculate the voltage with both RSG and RL is connected. So after that, we have to calculate the AV. So the first AV is nothing but the VO by V. and second AVS is equal to, so when why AVS, because we are now connected the source resistance, that is RSG. So at that time our AV is equal to AVS now, so we are only denoting that with the difference with the AV, so that is VO dash upon VI. Again AVL, when we connected the load resistance, so it will be VO double dash by VI, and last is nothing but the AVSL, when the source and load resistance both are connected, what will be the gain at that time. So this is how we can calculate the gain. Now next part is what? We have to do some theoretical calculation. So these are what the practical calculations, all the practical values we need to simulate or we need to obtain by the hardware. So these are the theoretical calculation. So we can calculate the AV as is equal to GM into RD. This minus sign indicate that it is 180 degree out of phase. So GM into RD. So how to calculate the GM? So GM can be calculated with the input and output. So output is current and input is voltage. So we know the input voltage and output current. So as in the first experiment we have considered, that is input is what? Input is what now? 50 millivolt, and what is the output? Output is the current. The current is what? It is 1 milliampere, and now the input is what? 50 millivolts. So if you take the ratio of it, so we can find out the GM, and if you multiply it with the RD, that is the drain resistance, so we can directly find the GM value. So this GM can be obtained. So using this GM and RD value, we can find the AV. Again we have to find the AVS. Again we have to find AVL and AVSL. So these calculations to be done when we got the proper result. So we'll take the result first, we'll implement the circuit, and again cross check whether the practical value and the theoretical values are matched. If it is matched, then it is fine. The last part is our experiment is what? We have to take the frequency response of this amplifier. So how to take a frequency response? In the simulation it is very easy. We have to simulate it with the AC analysis. So in that we can got the magnitude and phase plot of it, and again we can check the mid frequency gain, and again we find out the higher cutoff frequency and lower cutoff frequency. So in that we have to change the value of capacitor, this bypass capacitor and shunt capacitors. Again we try to verify and we try to cross check what will be the effect of these two capacitor on the gain and on the bandwidth. So now we'll directly move towards the circuit implementation.